Dear students, welcome to my channel. The topic of this video is F test and T test to check variable significance. In this video, exercises on multiple linear regression is covered. Now let us start. In my previous video, I have already explained the F test and T test concept, derivation and exercises. In this video, specifically exercises on multiple linear regression. When we apply F test and T test for multiple linear regression problem, we require to state null hypothesis and alternative hypothesis. In null hypothesis, we state that the variables are not significant, while in alternative, we place a statement that the variables are significant in nature. So this is the null hypothesis and alternative hypothesis respectively. Formula for the F test formula: F is equal to MSR divided by MSE. MSR is mean square due to regression and mean square error. MSR is nothing but ESS by K and MSE is nothing but RSS minus N minus K. So this is the numerator part and this is the denominator part. Degree of freedom for the numerator part is K, while the degree of freedom for denominator part is N minus K minus 1. I have already published the video on F test and T test, and from where you will get all the detailed information for F test and T test. T test formula: T is equal to statistic minus parameter divided by standard error. When we use simple linear regression, the formula is like this, and when we are using multiple linear regression, the formula is like this. This formula is specifically for two independent variables. So when two independent variables are there, we require to consider coefficient of correlation. When one independent variable is there, there is no need of correlation of coefficient. So this is the change in the formula. Statistic, whatever stated in our alternative hypothesis, that variables are significant. So in statistic, we are putting the value of the slope which we get from the multiple linear regression, and parameter is nothing but the null hypothesis. Here we keep that variables are not significant, therefore we are taking the 0, and this is nothing but the standard deviation of statistic or standard error with respect to input. Let us start with the exercise. This data is given. Total 8 number of records are there. x1 and x2 are independent variable, while y is dependent variable. This is a linear regression equation we got from this data. For this problem, the confidence interval is given 95%. Question is apply F test and T test. Here we first specify the null hypothesis and alternative. For F test, we are taking all the variables in simultaneously, because F test is applied on all variables simultaneously, while we apply the T test for each independent variable. So when we state the null hypothesis and alternative hypothesis for T test, at that time we require to specify as a different independent variable. As this is equal to 0 and not equal to 0, therefore it becomes a two-tailed test. When the exercise comes on F test and T test, we require this set of values. First three columns are nothing but given in the problem statement, that is nothing but our data set x1, x2 and yi. From regression equation we can calculate the predicted y. After that, RSS, ESS, S beta 1 and S beta 2 is required. RSS is nothing but the difference between the actual and predicted value. We take the difference, make the square and take the summation. And for ESS, it is difference between the predicted value and the average value. So we take the difference, make the square and take the summation. And this S beta 1 and S beta 2 is nothing but the standard deviation with respect to x1 and x2. This is the average of x1 value and this is the average of x2 values. Now here in our data set, total 8 records are there and 2 independent variables are there, and degree of freedom is N minus K minus 1, which is equal to 5. This is the formula for F test. When we put all the values from the table, we are getting the value as 64.37. Now here we require to take two degrees of freedom. First is for numerator and second is for denominator. For numerator, that is nothing but the number of independent variables, therefore it is 2, and for denominator it is n minus k minus 1, which is equal to 5. Now their intersection comes as 5.79. Now here we can check that the values from F table calculation is 64, while from table it is 5.79. To reject the null hypothesis, this value should be greater than the table value. Now this value is greater than table value, we are rejecting the null hypothesis, and it means that the variables are significant in nature. So 64.37 is greater than 5.79, null hypothesis gets rejected, and parameter b1 and b2 are significant in nature. Now t-test calculation. For t-test calculation we require specifically this x1 minus x bar square and x2 minus x bar square, and also we require the correlation coefficient. Now we see the calculation for the t-test. T is equal to, we are getting the parameter as 3.1479 minus the, because we are keeping alternative hypothesis that this variable or value is significant, and in null hypothesis we state that it is not significant, so this is the 0 value. Now to calculate the S beta 1, this is the formula. Only the change is that when we are taking the more than one variable, we require to consider the correlation between these variables. Now here two variables are there, we are taking the correlationship between the x1 and x2. Correlation comes as minus 0.88. We are putting the values into the formula, and after calculated the standard error we put into the t formula, and we are getting the 3.79. Once we get this value, we require to check the t table. In t table we are going for two-tailed test. The degree of freedom is 5. Now in problem it is given as a 95% confidence, so 95% confidence comes at this range. Now we can check that the answer is 3.79, so it is going somewhere in this range of 0.02 to 0.01, that is 98 to 99%, so it is satisfied. So calculated t value is 3.79, 95% confidence is satisfied. We are rejecting the null hypothesis, and parameter b1 is significant. Now we will check for the next parameter, that is beta 2. So similar as previous calculation we can do, only change is here we require to take this variable, and here the standard deviation with respect to x2 variable change. After that, when we calculate the final t value, which is coming as minus 1.73, now we require to check with the t table. When we check, as it is two-tailed test, we can check for the positive side also, because it is same on the symmetric side. Now when you see the 1.73, so it will come into this range of this 1.73, it will come into this range of 1.4 to 2.0, that is between the 0.10 to 0.20, that is 90 to 80%, and our given criteria is of 95%, so it is not satisfying at 95%, so parameter beta 1 is insignificant. But this 1.73 is lie at a level of 85% of confidence, so 85% is satisfied, but 95% confidence is not satisfied for this variable. That's why the parameter, this is not beta 1, parameter beta 2 is insignificant. Now standard error for MLR formula. When we are using multiple independent variables, so we require to consider the correlationship between that variables, and that we require to use including standard error formula. So when more than two independent variables are there, it becomes very difficult to do the calculation manually. We can write down the program, and from the program we can choose the values. So in most of the exercises you will see that when multiple independent variables are there or more than two, we are not doing the calculation, because calculation is very tedious. So we are getting just table like this, and from this table we are doing the work. For example, such type of table comes, and based on that table we apply the t-test. Now we start with the second problem. This is exercise 2. We require to apply the f-test and t-test. Confidence interval is 95%. 4 independent variables are there. This is the equation of regression. 12 records, k equal to 4. This is the degree of freedom. Now first we apply the f-test. Then for f-test we specify the null hypothesis and alternative hypothesis as same as our previous problem. Then we do the calculation and we find out all the values related with this. Now RSS and ESS and YCAP. we are putting the values into the formula and we are getting the answer 5.14. Now here 95% confidence is given, therefore we are checking the table. Now degree of freedom for the numerator is k, which is equal to 4, and for denominator it is degree of freedom, which is equal to 7. So we take the intersection of 4 and 7 and we can check that 4.12 is less than whatever we calculated, 5.14. so therefore we are rejecting the null hypothesis and accepting the alternative hypothesis, means all variables are significant in nature. 5.1.4 is greater than 4.12, therefore this is rejected and parameters are significant in nature. For t-test we require to use all this regression with respect to first variable with second, first variable with third, and first variable with fourth, and it is very difficult to manually to find out this table, so we are directly using the table like this. Now sometimes in exam the coefficients, standard error and t-stat is given. Here I am not giving the concentration on p-value concept. Now even if t-stat is not given, when we divide coefficient by standard error it will give the t-stat. So we just require to concentrate on this column and we can get the result, or otherwise we have to divide coefficient divided by standard error. Now check for this example. Now here the value is 1.641. If we check that the degree of freedom is 7, so if we check for 0.05, that is two-tailed test, we can see that the value is between 2.36, and if we check 1.6 it will lie somewhere between 1.41 to 1.89, that is between the 90% to 80%. So it is not satisfying at the 95% of confidence. That's why beta 1 is insignificant. Even we can check with the p-value. P-value should be less than or equal to 0.05, then the variables are significant in nature. Now similarly we can check for 1.68. we can easily see that it is not satisfying between the 95% or more than 95%. Then next variable 0.601, still it is coming on the left hand side, not satisfying. 0.012 not satisfying. So only first parameter that is first parameter is satisfying the criteria of 95%, otherwise all variables are insignificant in nature. Now go for the exercise 3. Here again two independent variables are there. Apply the F test and T test. Confidence interval again 95% is given. This is the regression equation for this set of data. Now all this you require to generate the F test table. Now here F test table generation is very much easy. We require to apply the formula and we require to find out the summation. Now here this is the exercise for you people, that you just put the value into the formula and just check with the F table and degree of freedom of numerator and denominator whether these two independent variables are significant or not. Now T table is given. From the T table, by seeing the p-value also we can take decision that this is significant, and this is not significant. If we check that degree of freedom and if we check that 18 point, so it is greater, satisfying. 0.9 it is not coming in this range, it is not significant, and this is minus 3.00 value, and we can check that it is again this is negative, but it is a two-tailed test, so we can map on the opposite side also for checking purpose. This is again coming into this range, so this intercept and x2 variable is significant while x1 is not significant. Now exercise 4, this table is given. We require to apply the F test and T test. This is the equation for this data. We can generate the F test table. Again exercise for you people to just put all the values into the formula and just check with the F table whether all variables are significant or not. This is the T test table, and here we can easily check that point less than or equal to 0.05, 0.05, 0.05. So all are significant in nature, and if we see this value, you can check that all the values when they are greater than 95% they are more than 3.18, and all these values are greater than 3.18. So all variables are significant in nature. So in this way we can apply the F test and T test for multiple linear regression problem to find out the significance of all variables simultaneously, or we can check the significance of each variable independently. So that's all about the multiple linear regression and the testing of significance variable. Thank you.